Okay, so as we move forward and start to actually calculate these confidence intervals, we're going to follow the same pattern we have been with sampling distributions. So we will focus in our second section, 6.2, on proportions, and then in 6.3, we'll focus on means. So we are doing all things P and P hat in this section. And so before we jump in, let's review the 3 conditions that must be met before we can calculate a confidence interval. So that first one, remember, is random. We must take a random sample. That is just good statistical practice. Second, we have to know that our sampling distribution is normal by showing that n times p hat is greater than or equal to 10, and n times 1 minus p hat is greater than or equal to 10. Now you might be saying, well, wait a second, we've been using P, well, the population percent. But remember, in this unit, we don't actually know that population percent. So that's going to be pretty difficult to achieve. Instead, we're going to use our sample percent because it's the best that we can do. And then the last one is that our trials must be independent, which we achieve assuming that our sample size n is less than 10% of the population. All right, and so when we start using that general framework, remember you've got your point estimate, your statistic, which in this case is p hat, plus or minus a critical value. That critical value is a z-score. Yep, you heard me right. Z-score, that's coming back, times the standard deviation, which we learned in our last unit for our statistic, is p hat times 1 minus p hat over n. All right, and so if we jump back to our formula sheet, sorry, it's going to take me a second. Here we go. So our formula sheet will show us this formula, and that's what I want you to see. Okay, so we are here. Notice confidence interval. It gives you the general framework, that statistic plus or minus the critical value times the standard error. The formula sheet uses that language, so that's what we will adapt to. And then if you keep scrolling, this starts to talk specifically about those formulas. So here, if it's for one population and we have one p hat value, then our sample standard deviation is this guy. And notice standard error is what runs along the top. So if it says standard error, then you should jump to this backside to check which formula you're using. All right, so that's where you would find that. So let's talk about the critical value. Do you remember way back in Unit 1, we studied the 68, 95, 99.7 rule, which we called the empirical rule. All right. Hopefully you're saying, yes, I do. And remember that in that rule, we know that the mean mu is in the center. Okay, and if this is a standard normal curve, we've got 0 there. Then we go up 1, up 2, up 3 standard deviations. Down 1, down 2, down 3 standard deviations. And what those percents, those 68, 95, 99.7 represent are these guys. Whoops. So this is 68%. This is 95%. And this is 99.7. And because we're on the standard normal curve, then our z-scores for 95%, for example, would be plus or minus 2, right? Think about that critical value, plus or minus the z-score. Okay, so if we want that 95% confidence interval, we're going to get a little more specific than -2 and +2 because those are ultimately somewhat rounded numbers. But we would know that we have 95% in the middle with a mean of 0 and a standard deviation of 1, right? Mu is 0, sigma is 1, always, always if we are using the standard normal curve. And so we would punch in our calculator inverse norm. I'm a little bit foreshadowing our next problem. 0.95, 0, and 1. If we could put the center, if you are that person and you can determine the tail, right? Your calculator operates with a charger, or inverse norm. Now, if not, and you can only do the area to the left, then this area is 0.025. It even says that for us. I didn't notice that. And so you would say 0.025, 0, and 1. And that'll give you that -2, you'll know, or -1.96 to be exact, this guy. And you'll know that then your other z-score, your other critical value must be positive 1.96. And so example 1, we're going to walk through this together. So how can we use the calculator to find the z-score for an 80% confidence interval? So we're assuming that normal condition is met. This is why the normal condition exists. If it's not normal, then we can't find a z-score. And if we can't find a z-score, we can't calculate our confidence interval. So we are going to first draw our curve. We know we have a negative z-score and a positive z-score. And we know 0 is in the middle. And we know this area right here is 0.80. So in our calculator, we will say inverse norm, 0.80, the mean of 0, and the standard deviation of 1. Specifying the center is what we have encompassed. Or we'll do inverse norm. Okay, and if we need this area that's to the left and the right, we have to think about, okay, we've got 80% in the center, which means 10% is to the left and 10% is to the right. So you would say 0.1001. And now I'm going to punch that in my calculator. And I get -1.28 and positive 1.28. So this would be plus or minus 1.28 will be my critical value. All right, and so if you're watching this, and you are filling out the notes, I would encourage you to press pause and try A, B, and C on your own before you just watch me do it, right? But I'm going to keep going so that you have a chance to follow along or check. Okay, so 90% confidence. I draw the curve every time. 0, negative z, positive z encompasses 90%, which means on either side we have 5%, 0.05. Okay, so we would do inverse norm, 0.90, 0, and 1. Center, or inverse norm 0.05, 0, and 1. And either way, we will get plus or minus 1.64. Okay, remember that second one that I'm writing, that's if your calculator operates on batteries. So if you're borrowing one of my calculators, or you have an 83 or an older version of the 84. If you charge, then you can do that center tail. Okay, so the next one, we have 96%. I'm actually just going to cut and paste this one I already drew. And so I'm going to make that not 90. Instead, it'll be 96. Okay, so if 96% is in the middle, then 4% is not included. Divided amongst my two sides, 0.02 and 0.02. Okay, so again, we're going to cut and paste what we've been writing because it's all the same. So we would do 96 or 0.02. And we would get plus or minus 2.05. And then last but not least, 98%. Okay. So in a 98% confidence interval, we've got 98% in the middle. So we have 2% total on either side, which is 0, 1 and 0, 1, 1%. So then here, plus or minus 2.33 if we round to the second decimal place. And remember, all that inverse norm is coming from your calculator hitting second vars, so your distribution menu. Okay, so that brings us to our practice assignment for today. You are going to check your conditions, so the random, normal, and independent conditions. And then you're going to find some z-scores, some critical values. Okay, we'll talk to you tomorrow.